Hey, hi guys. Today we're going to learn about the bubble sort algorithm. So let's jump in. So let's start with what is bubble sort. So bubble sort is a simple comparison-based sorting algorithm. So it works by repeatedly stepping through the list, comparing adjacent elements and swapping them if they are in the wrong order. So let's break down the process. So start at the beginning of the array. It compares first two elements of the array. So it swaps if the first element is greater than the second, and move to the next pair of adjacent elements and repeat the comparison. So once you reach end of the list, the largest element will be the end. So this will be repeated for the unsorted portion of the list. Let's look at the key features of bubble sort. Simplicity. So bubble sort is one of the simplest sorting algorithm to implement and understand. Time complexity. So the worst case is O of n square happens when the list is in reverse order, and the best case is O of n. So it happens when the list is already sorted, and also average case it also of n square happens with the random data. So the space complexity is O of n always because there is no additional memory is required for the bubble sort. We're going to modify the same array and the optimization. See, bubble sort can be optimized by checking the swaps are made in a pass. If no swaps are made, the list is already sorted. Now that we understand bubble sort, let's move a step-by-step walkthrough to see how it works in action. Now let's dive into the practical demonstration of the bubble sort. So here I'm going to generate random numbers for the bubble sort. So initially I want to go with 6. Yeah. So in the code section, if you see the variable n holds the size of array. So which helps to determine how many passes we need. The swapper flag here. The swapper flag used to optimize the algorithm by checking if a swap occurred during a pass or not. If no swaps happen in the pass, the array is already sorted and the algorithm terminates shortly. So here we have two for loops, the outer for loop and the inner for loop. So the outer for loop runs up to n minus 1 times, where I represents the number of completed passes. So with each pass, the largest unsorted element is moved to its correct position at the end of the array. So swap is set to false at the beginning of the every pass to track whether any swaps occur during the current pass. And the inner loop. So the inner loop handles the actual comparison and the swapping of the adjacent elements. So the loop runs from z of 0 to n minus 1 minus I times. So minus I ensures that with each pass, the already sorted elements at the end are excluded from the comparison. Here, the if condition checks the largest element. So we always compare with the first element with next. So if the first element is greater than the next element, so there will be a swap. As we observe the sorting process, each circle represents the number from the list we are sorting. So initially, the circles are arranged in an unsorted order. So as the algorithm progresses, the circles move around, reflecting changes in the order of the numbers. So the algorithm works by comparing adjacent elements and swapping them when necessary. So when two numbers are out of order, the circles will be physically swapped. So which helps to illustrate the sorting process. So as elements get sorted, you will notice that the circles from those numbers stop moving. So while the other continue to rearrange. So this step-by-step progression helps to show how the algorithm gradually sorts and the entire list. And by the end, all the circles will be in correct positions, demonstrating that the list is now sorted. So in the first pass, the algorithm iterates through the list, compares adjacent elements. So we start with first element 87. So now 87 is greater than 59, which is true. So if this condition satisfies, the swap logic will going to execute. Yeah. Now 87 move to index 1. Now 87 is going to compare with 27. So it's again satisfies the condition. So there will be one more swap. Now 87 move to index 2 here. So 87 is greater than 45. So which satisfies the condition and there will be swap. So again 87 move to index 3. Now 87 going to compare with 11. So which again satisfies. So it's going to one more swap. So the last 87 move to index 4 and 87 going to compare with 57. Yep. So at the end of the first pass, the largest element 87 has been moved to the correct position. That is at the end of the list. So this is why the algorithm is called bubble sort. So the largest element bubbles up to the top of the array. So we're at the second pass and we again start with index 0. So we're going to compare the 59 with the 27. So 59 moved to the next position because of the swap happens between the 59 and 27. So now we're comparing the index 1 with index 2. So 59 is greater than 45, which satisfies the condition and there will be swap. Now 59 moved to index 2 and the 59 going to compare with 11, which satisfies the condition. So there will be one more swap. At the end of the second pass, and we are comparing the 59 with the 57. Yes. See, the 59 is reached to just before the largest number, that is 87. So 59 and 87 considered to be sorted. From now, there will be no participation in the comparison. Now we're in the third pass, so we're again going to start with index 0, that is 27. So 27 is greater than 45, which is false. There is no change. Now index is at 1, so at index 1 we have 45, so 45 is going to compare with 11. So 45 is greater than 11, which satisfies the condition, so there will be a swap. Now 45 moved to index 2 and index 2 is going to compare with index 3. So 45 is greater than 57. So the condition is false and there will be no swap. So in this step, we can see the 57 is fixed. So 57, 59, 87 sorted, and from now these numbers not going to participate in any comparisons in the further process. So we're at I equal to 3, which means we're in the fourth pass and the first element 27 is going to compare with 11. So 27 is greater than 11, which satisfies the condition. So there will be a swap. Now the comparison between 27 and 45. 27 is greater than 45. The condition is false, so there will be no swap. Here you can see all the elements of the array got sorted. So the process terminated the fourth pass instead of theoretical fifth pass due to the absence of swaps, which indicates that the list was already sorted. Thank you for watching. If this tutorial helped you to understand bubble sort better, please give it a thumbs up. Share it with others who might find it useful, and subscribe to our channel for more in-depth algorithm tutorials. Have questions or suggestions? Leave a comment below.